Okay, today we have mechanics. This is our first lecture. Previous was only introduction to physics. So today we'll start our course outlines about mechanics. So what is mechanics? What means mechanics? This is a branch of physics and in which we deals about what? We deal about
Motion.
motions, yes. So, mechanics, the branch of physics, which deal about the study of motion, motion study, mechanics. And then there are two types of motion studies. One is called kinematics, and second one is called dynamics. These are two branches, there are two types of mechanics. Kinematics and dynamic. In kinematics, we study same motion, but in kinematics, we study without the cause of motion. For example, we study the speed of body, velocity of a body, or acceleration of a body, but without the cause of motion. It means without the force which produce motion. So without the cause of motion, you can say without cause. Cause of motion means force. But in dynamic, we study actually force study. We study, for example, speed, velocity, acceleration, along with the cause of motion. Along with the cause of motion, we also study force. For example, who applied force? If acceleration produce, speed produce, velocity produce. So how this velocity produce? Who applied force and how much force is applied? So mechanics, motion of study, yeah, study of motion. Then mechanics divided into two types. One is called kinematics. Second one is dynamics. In kinematics, we study just motion, not the cause of motion. But in dynamic, we study the cause of motion. Like we also include force with kinematics. Okay, for study of kinematics, first one, we ignore all other forces, like we ignore all external forces, like friction force, gravitational force. We ignore all these things. Uh, it may be one-dimensional motion or two-dimensional motion. Next thing, for kinematics, we consider, yeah, we assume that all bodies, yeah, all objects are like particle nature. They behave like particle nature. So, anyone know about particle? That what is particle in physics? What we can, why, for example, particle means what? Can we say this car? You can see graph. Is this a particle or not? So, any idea about particle?
Professor, I think particle is any object under study in physics.
Okay, excellent. Actually, in physics, particle means that, for example, if one body, yeah, if we have mass m, if this body moving in forward direction, and all the parts of this body moving in same direction, so we call this is a particle nature. For example, if we see this car moving forward, this is matlab straight. Uh, you can see, for example, motion in straight line. But if you see the tires, so tires are moving in a circular path. So there are two different types of motion in this car. One is straight engine moving straight forward, and tires are moving in circular path. So we cannot say that this is a particle. Correct? So a particle is that body which all particles are moving in the same direction. So If we take car, if we take any other body, so for kinematics, we will consider that body. That body is acting like in a particle, so particle nature. So we present, for example, from dot. Yeah, we present dot, yeah, mass. Although in car there are different motions, maybe there are some parts in car that moving, for example, in different direction. Engine moving forward, tire moving circular motion. There are some other parts which are moving, for example, clockwise, anti-clockwise motion. But for kinematics, we will ignore these motions. We will ignore these parts. We will say this every body act like a particle. Okay. So motion along one dimension, motion along x-axis or motion along y-axis. So first of all, we have position. What means position? So position actually show location. Location with respect to some reference point. We fix some reference point like we are on x-axis. So our origin or our reference point is, let's suppose, 0. So for example, we have 1, 2, these are unit distance, like 1 meter distance, like 1 kilometer distance, 1 mile distance. So this side we consider this as positive, and this side we consider is negative. These are location. A body, for example, are positive side or a negative side. But these are convention, only convention. You can use, for example, uh, left side is positive or right side is negative. But these are convention. We use right side is positive and left side is negative. But we need to point out a reference point, a starting point. Same if we are moving vertical motion, for example, if you are standing on a table. So for example, we consider upward, above table, we consider this is y positive axis. Downward we consider is negative y-axis. So position means location of a body with respect to some reference point, positive side or negative side. Yes, any question, Simin? Okay, no question. Okay, we have position time graph. Position time graph. Actually, position time graph shows speed of a body. Speed. Uh, you can see from the graph, a body start from A. Let's suppose reference point is 0. This is reference point. Positive x-axis, yeah, negative x-axis, this is reference point. Starting a body is A. So let's suppose A is 30 away from 0. Let's suppose 30 away from 0. In respect to some reference point, we will consider some reference point, starting point. For example, I told you the table value that, for example, and you are standing on table. Yeah, for example, you are standing on surface of earth. So surface of earth, actually this is our reference point. Upward distance, we consider this as y positive. Downward distance, so we consider as negative. Correct? So these are just reference point. You can say on x-axis we have positive x side or negative x side. So A position, then B position, C position, D position. So you can see from A to B. Correct? In this case, body moving from A to B. Same, for example, time spending here. So this side is delta t and this is delta x. X means distance. You can say yeah, location is changing. But if, for example, location is changing positively, if you are moving in positive, correct? So the slope is positive, slope value. But if you are moving downward, it means if you are moving toward your reference point, So this slope is negative. Correct? So different position, for example, position number A, starting point 30, after some time we reach 52, after, for example, some time reach 38, D, then again, for example, 0, then 37, minus 37 and minus 53. Minus 37, minus 53 means they are moving in opposite direction. Yeah, for example, one side is positive, other side will be negative. So position time graph, but we will discuss this one. The position time graph show speed or velocity or something. But we will discuss this graph in velocity. Okay, next thing is distance and displacement. Any idea about what is different between distance and displacement? Yes, yes, I'm
Uh,
here. Yes,
so the distance is basically how far the object goes, but displacement is the difference between point A and B. So from point A and to point B, how far did the object go? That would be the displacement of the object.
yes, excellent, excellent. Anyone else? Yes, distance and displacement. Okay. Distance and displacement. Actually, distance means the actual path covered by a body. Actual path, your total path covered by a body is called its distance. Where displacement is the shortest distance between 2 points. Shortest displacement, yeah, shortest distance. Like what? For example, a body start from this position. This is starting point from X. So first body cover distance, for example, 3 kilometer up to Y. Then from Y start up to Z, 4 kilometer. So what is total distance? Yeah, what is distance? So actually, distance means total path covered by a body.
3 kilometers plus 4
Yes,
kilometers.
total path. So total path means
7.
3 plus 4. So 3 plus 4 means 7 kilometer. This is actually the distance. But displacement is the shortest distance between 2 points. For example, starting point is X, this point, and end point is Z. So this distance, this is the shortest distance. So this distance is called what? Displacement. Correct? Distance,
Yes, sir.
actual path, and displace means the shortest distance between 2 points. For example, if a body start from one position, let's suppose we have position A, body start and reach B, then reach C, then reach D, then for example E. So what is total distance? So total distance is the distance between AB, then BC, then CD, then DE. So this total distance, yeah, this total path is called what? Distance. But what is displacement? Displacement means the shortest possible distance between starting point and end point. This point, for example, start from A and E. So this point, yeah, this distance is called displacement. Correct? Distance is always positive, but displacement may be negative. Zero possible, negative possible, and also positive possible. It depends upon the location, it depends upon initial and final position, starting and end position. Okay, you can see distance. For example, in this graph, a body start from A, correct, with different location, reach B. So this dotted line, this is distance, and shortest distance black, this shortest distance is displacement. So path is always, yeah, distance is always positive. Unit of distance is meter, SI unit, system international. Okay, speed. Now we have speed. So what is speed? Actually, speed, that how fast something moving, yeah, how fast a body is moving is called speed. Uh, but speed doesn't tell about the direction because speed is a scalar quantity. We don't need direction. And the formula of speed is v is equal to distance covered divided by time. Distance, yeah, total distance covered divided by time. When we take average value, so average is total distance covered by time. For example, about start from A position, reach B. This distance is, let's suppose, 10 meter. Body cover this distance in two, you can say seconds. Then from B to C, and this distance is, let's suppose, 20 meter. This distance covered in 4 seconds. Then from C to D, and this distance is, let's suppose, 50 meter, but body cover this distance in 5 seconds. So when we talk about one point, for example, from A to B, so speed is equal to what? Speed is equal to distance covered divided by time, where distance is 10 divided by time is 2 seconds. So we can say that from A to B, speed was 5 meter per second. Unit is meter per second. Okay. Then from 20 to 4, sorry, B to C. So 20 divided by 4 is 5. Then from C to D, 50 divided by 5. So this is distance. But if we are talking about average distance, so average distance, average speed, sorry, is equal to total distance covered, total distance divided by total time taken. So total distance covered from A to B, 10, 20 and 50. Total equal to what? 80. Divided by total time taken is 6 plus 5 equal to 11. So this is average speed. Clear? What is speed? Speed actually, the distance covered over time, yeah, distance per unit time is called speed. When we are talking about average, so total distance covered divided by total time taken, and we don't need what? We don't need any direction for that. Displacement, yes, displacement is also movement of particle, but in displacement, we consider position, end point and starting point. We don't consider what happening between these A position and last position. So we find shortest distance between these 2 points. Okay, average speed. For example, this question, a body start from X, reach Y, cover 3 kilometer distance, then from Y start reach Z, cover 4 kilometer distance. So what will be the distance? Sorry, what will be the average speed? So average speed is equal to what? This symbol is for average. Average speed is equal to total distance covered divided by total time taken. So in this case, first 3 kilometer plus then second 4 kilometer divided by what? Total time taken. Total time taken is 2 hours. So what is the speed? Yeah, average speed is equal to 7 divided by 2 equal to 3.5 meter per second. This means that at every second, body cover 3.5 meter distance. Correct?
5 kilometer.
Yes, excellent. Now, displacement, as I told you that displacement is the shortest distance between 2 points. We use the formula for displacement is delta x, change in displacement equal to final position minus initial position. X is location or position. So final minus initial. Same unit of displacement is also meter because this is also distance. But distance is always positive, but displacement depend upon position. Displacement may be negative, positive, also zero. For example, you start from your home and reach, for example, American University campus. This is, let's suppose, 10 kilometers away from your home. Again, after taking classes, you reach again home. So what is your distance cover? So in this case, distance cover is 10 plus 10, 20 meter. But what about your displacement?
Displacement is 0.
Displacement is 0 because xf
Zero.
minus xi, because both position are same, starting from 0 and again you reach 0, so 0 meter. Although you cover 20 kilometer distance, but your displacement is 0. Great, excellent. Uh, these are okay. We have velocity. So when we are talking displacement, so speed, then we will discuss velocity. Same speed and velocity, but the difference between,
Excuse me, sir.
yes, Mr.
In the previous slide, what XF and XI stands for?
These are final position and initial position, starting position or end position.
Okay, sir. Okay. Thank you.
Welcome. Okay, same. We have velocity, but velocity related with what? Speed related with distance, and velocity related with displacement. When we are talking with displacement, so then speed is called velocity, because then we need to compare, then we need to mention the direction as well. So simply you can define the velocity is that, for example, velocity means how fast something moving and in which direction. So when you say direction, so automatically your speed become velocity. Correct? And same, the formula of velocity is, because this is vector quantity, so we need an arrow. V equal to what? Change in displacement divided by,
Distance
yes,
by time.
yeah, you can say that xf minus xi, change in displacement divided by final time minus initial time. Correct? You can say, for example, final position or v is equal to what? Rate of change of displacement. When you say displacement, so then speed is called velocity. But when you say distance, then speed is called what? Then speed is only speed. When you say distance, then speed is speed. But when you say
But
displacement, then speed is called velocity.
it will be velocity.
Yeah, velocity, excellent. For example, in this question, what is difference between speed and velocity? Again, same previous example. First distance, body cover 3 kilometer from X to Y, and then from Y to Z, 4 kilometer. Can you see this black window here?
Yes, sir.
Yes,
Yeah,
sir, we can see that it's disturbing.
Yeah, this is disturbing. Why this one? Okay, let me again share my screen.
Professor, can you please repeat the formula part once again for velocity?
Yes, I'm going to work on velocity example. Can you see the screen?
No, it's good, sir.
Okay, so now in this case, find out velocity and speed. So first of all, speed. You know that speed is equal to what? Speed is equal to distance divided by time. Yes. So distance cover. Total distance is 3 plus 4. So 7. Divided by what? Divided by total time taken. Let's suppose total time taken is 2 hours. So this will be 3.5 meter, yeah, kilometer per hour, because time is given in hours and this distance is given in kilometer. So we have 3.5 kilometer per hour. But when we say velocity, so velocity actually final position minus initial position divided by what? Divided by total time or change in time, final time and initial time. You can say final time minus initial time. Yeah, change in displacement. Sorry, change in displacement divided by change in time. Now, what is displacement here? So displacement is shortest possible distance. You can see this distance. This distance is your displacement. So how you can find this distance? Who will tell me how we can? Yes,
Pythagorean theorem,
yes,
sir.
yes. So we can
And
find
that's
this
5.
distance by Pythagoras theorem, that we have c square is equal to what? A square plus
A squared
b
plus
square.
B squared.
Or c is equal to what? A square plus b square
Under
divided
square root.
under the root, under the square root. Correct? So let's suppose one side is A, this side is A, this one is B. So A square, 4 square means what? 16 plus 3 square is 9. So 16 plus 9 equal to 25 and 25 equal to plus minus 5. Correct? But this is distance, so we take only positive plus 5 because distance always positive. Now displacement is 5. So 5 displacement divided by what? Divided by total time taken. Total time taken is 2. So velocity is equal to 2.5 kilometer per hour. This is difference between velocity and speed. In speed we study total distance, but in velocity we study displacement. Okay, same we have average velocity. So average velocity is total displacement divided by total time. For example, if a body starts from A position, reach B, then C, then for example D. Distance cover or displacement cover, for example 10 meter, then 20 meter, then 40 meter. First cover in 2 seconds, second for example in 3 seconds, and next one is in 4 seconds. So if you are talking between these two, so this is only velocity. Velocity is equal to what? Distance cover, yeah, displacement, 10 divided by 2, so equal to 5. But when you are talking about average, so average velocity from A to B, yeah, A to D total. So total displacement cover. So you need to start from A to D, total distance or displacement cover. So 40 plus 20 plus 10 equal to what? 70 divided by total time taken 2, 3 and 4. So 7 plus 2 equal to 9. So 70 divided by 9 equal to what? 8 point something, 7.77, no, 70,
7.78, yeah.
yes, so 7.78, yeah, 7.7, so we can say 7.7 is the average velocity, meter per second, yeah, kilometer per second. One another thing, dimension, what is dimension? Anyone, any idea about dimension? One another thing, like we have in mathematics, x-axis, y-axis, these are called dimension, one dimensional, two dimension. This dimension is a little bit different from the mathematical dimension. So in physics, what is dimension? Here given that dimension of average velocity is L over T, length over time. Yes, any idea? Yes, okay.
Professor, I have a question.
Yes, yes.
Professor, how this average velocity is different from the velocity that we just calculated in the previous slide? We said that velocity is the difference between the displacement over the total time, or the difference between time. But here you didn't calculate the difference between time, rather you just calculated them, or you summed them all together.
Okay. I will tell you that. Okay, let me explain again. Let me remove these. For example, a body is on x-axis, yeah, on horizontal x-axis. Let's suppose we have this distance. For example, starting point, let's suppose this one is 0. We have 1, then 2, for example, 3. Let's suppose we have 20 plus. A body is on 2, for example, a body is standing here. Correct? So this means initial position is 2 meter. Correct? Now, timing this one, for example, starting point, initial time is 0. This body start motion. Correct? Reach position 20. So final position is 20. And what about timing? For example, let's suppose time starting was 0. So this body covered 20 meter, yeah, from 2 to 20 in just 6 seconds. So how we can say the average velocity or velocity? So by this formula, xf minus xi divided by tf minus ti. So what is final position? Final position is 20. What about initial position? Starting was from 2. Divided by what? Divided by final time is 6. Correct? And initial time was what? Initial time was 0. So we can say that 18 divided by 6 equal to what? 3 meter per second. So this body cover 3 meter in each second. Correct? Correct. This one is for when we are given final and initial values. But if you know, for example, in parts, first distance cover in 2 meter, yeah, 2 seconds, second cover in, for example, 5, third cover in 10. So then you need to add total displacement divided by total time taken. But xf minus xi, these are for different formula, for example, for different location. When different time is given, different location is given. Clear, guys?
Yes, sir.
Should I explain again?
Yes, teacher, thank you.
Okay, great, great, excellent. Okay. Actually, velocity is a slope. Now, next topic is what is slope? Any idea about slope? Yes. Think about it. Tell me, what is slope? Positive slope, negative slope. Yes.
A slope is, Professor, rise over run
Yes, rise over run means what? Excellent.
is the tangent, sir.
Yes, tangent means what?
And tangent means the adjacent side.
Okay.
That's the tangent, sir. So we take that side that is exactly in front of us over the adjacent side. For example, in here, delta x over delta t is the tangent of this, sir. And this is exactly the slope of that.
Yes, this one is slope. Excellent, mister.
And also, yes, and positive slope is, for sir, whenever a line passes from the first quadrant and the third quadrant, so that has the slope of positive. And a line that passes from the second quadrant and the fourth quadrant, that has the slope of negative, sir.
Okay, okay. Anyone else? What is slope?
That's what I know.
Yeah, it was great, excellent. Any idea about slope?
Professor,
Yes.
slope is basically the steepness of a line. So
Yes.
basically vertical change over horizontal.
Yes, excellent. Steepness of a line, correct. But what this means? What means slope? Steepness, rise over run. What these means? Yeah, rate of change. What means slope? Give me a real life example. What means slope? Yes, yes.
Well, it shows the direction of the movement. For example, if we say see the prices of products through time, the slope will tell us if the values or the prices were increasing or decreasing.
Yes, excellent. This is also correct, but again, not completed. Yes,
Professor, for example, how the steepness of a road, so we should take into consideration how steep a road is or how much it rises or falls, and that will bring difference in the speed. So in accordance to the steepness of a road, which a car is moving on, we calculate the speed, we take that into consideration. So that can be an example.